Hello and welcome back, everybody. Today, in this next section of geometry, we are going to look at something called translation and also glide reflection. So this comes after learning about what was it before? A reflection of a line. So that was the previous section of this. Okay. So before the last section, like I said, is we're learning about how to reflect off a line. So if you're given, like, say, a set of points or maybe a single point and you reflect it off the line, the result is that it becomes kind of like a mirror image on the opposite side, where the result is still going to be isometry. So in this case, in this section, we're going to learn about something called translation. So let's go ahead and define that first. A translation, or also known as a glide, is an isometry, first of all. So meaning that the shape of whatever it is that you're gliding or translating is going to be the same after you move it, such that it shifts all the points, all the set of points that are going to be in that set, horizontally and or vertically. So in translation, as to, like, what that means, you're basically taking a point and you're moving it left and right, up and down to some other location. So for example, this point, so here we have four different sets underneath, you can see. So a translation would be, for example, take this point A and move it over here to some other position over here. Now, when I move it, what I'm doing is I'm basically moving it horizontally by a certain amount and then vertically by a certain amount, which is the same thing as saying move it diagonally by a certain amount. So for the sake of simplicity, we're just going to go ahead and say that if you're moving it diagonally, then we're just going to move it horizontally and also move it vertically at the same time. Note that the shape of A, which is a point, is still going to be preserved in this case. If I take the second one over here, PQ the segment, you'll notice that if I move it left and right or up and down to some other position, the shape of it is still going to be preserved, and hence that's why it's isometry. Take this triangle over here, WTF. If I move it left and right, up and down, it's still going to be the same thing. The shape of that triangle is still preserved. So the triangle, the end result, the image, where this is the pre-image, is going to be a triangle that's going to be congruent to this one over here. And finally, for this last one, where if you have this happy face over here, if we move it left and right, up and down, doesn't matter where you move it, the shape of that picture is still going to be the same thing. Okay, so let's go ahead and write a translation as an equation so you can see how that works out. So since we said earlier that if you're translating something diagonally, it's really just a combination of moving it horizontally then vertically, then we're going to write it as the following then, just to make it a little bit easier for us. We say that a translation is denoted by the following. T, and then we have this little colon over here, xy, the coordinate, that's the original coordinate, and then we have a little arrow which indicates that we're going to translate into a new coordinate where you see that the notation is now x plus a comma y plus b. So what that means is that the x coordinate and the y coordinate of the old point is going to be added or subtracted by a certain amount. So here, rather than, just trying to go by that, let's go ahead and jump into an example so you can see what I mean. Note that on the right-hand side, once again, we're going to use the same set of points as the last time, but this time we're going to go ahead and try to use translation on it to see how this works out. So in part A, what I want to do is I want to use the following translation. T is going to be the name of the translation, so it's kind of like saying f of x. T for translation, more specifically. I want to take any point and then I'm going to translate it so that x becomes x plus 1 and then y becomes y minus 3 to find what is the image of ABC then. Okay, so let's go ahead and take it point per point just to see exactly what's happening. My point A, which is going to be 6 comma 2, right? That's my original point. That's the pre-image. If I were to throw it into this T, the translation, then the result is going to be the following. A prime, I guess that's going to be the new point, that's the image then as a result, is going to be, according to my equation, 6 plus 1 comma 2 minus 3. So note that 6 and 2 are the original values of the x and y, and then I'm going to add 1 to the x and then subtract 3 from the y. So then the result is that we're going to have A prime, which is now located at 7 comma negative 1. Now, in terms of location, that is going to be 7. So we're going to move over to the right by 1. And then we're going to go down by 3, it looks like. So this point over here, that is going to be the after image of A prime. So that's going to be 7 comma -1. So I guess the best way to kind of think of it is that if you have x plus a, then that means we're going to move to the right by 1 unit then, because that's exactly what's happening over there. But whereas if I have y minus 3, then that means I'm going to move it down by that same number of units. Because remember, y value is the vertical components, whereas the x value is going to be the horizontal components. So it only makes sense that y, if I add or subtract, I'm moving up and down, versus if x, if I add or subtract, I'm moving it left and right. So this is going to be down by 3 then, okay? So here, for example, like say if I have the following x, y, and then we have the translation, let's say that we have x plus 5 and then y and then plus 7, then this is telling me we're moving it over to the right by 5 units, and then we're going to go up by 7 units at that point. And then whatever that is, that's going to be my new result. So that's the idea behind the translation then, okay? All right, but anyhow, back to this problem right here. I'm going to take that point A and translate to 7 comma -1. So that's where A prime is going to be. We're going to go ahead and do the same thing for the other point then. So let's go ahead and do B right here, right? Because I want to do it for the entire triangle. So B is located at -1, 5. So if I put it into T, my translation, then that means that B prime is now going to be moved over right by 1. And then so that is going to be 0 because it's -1 plus 1. And then the y value is going to be 5 minus 3, which is going to be 2 then. So that is going to be my new coordinate. So let's see, go across by 1 and then down by 3. So then that means that this over here is going to be my new B prime point then, okay? All right, and then finally for the last one, point C, that is going to be originally 2, 2. So then that means C prime, if I want to solve for that, let's write down the work once again. So it's 2 plus 1, comma, 2 minus 3. So that is telling me that C prime, my new coordinate, is going to be at 3 comma -1. So 3 comma -1, I do believe that's located right here. So that's going to be C prime. And note how what's going to happen. So here's what I'm going to do next. If you draw the triangle ABC right here, so let's go ahead and draw that out. So here's ABC, there's the triangle. And then I'm going to draw the other triangle, A prime, B prime, C prime. You'll note that the two triangles, as I said, everything is preserved. The distance, the sides of the triangle, the angles of the triangle, because it's an isometry. These two triangles are congruent to each other. So it only makes sense that these two triangles are just going to look almost identical to each other, right? Notice the green triangle, if I move it to the right by 1 unit and then I move everything down by 3 units, then that result is going to give me just exactly the red triangle then, okay? All right, now here, let's go ahead and try to kind of like work backwards here, okay? So this time around, what I want to do is I want to know what is the translation. So meaning what is the equation, I guess, we're going to use in this case, so that B is the pre-image and then A is going to be its image then as a result. So let me go ahead and erase some of these guys right here just to kind of get those out of the way. Let's see, makes it a little bit harder every time I draw on this and then have to erase it. But hopefully you guys get the idea right there. Okay, oh, there you go. Make it a little bit easier. Get rid of it, and there it is. Okay. Oh, actually, I'm going to get rid of these too. So, can it? Oh, there it is. Much better. So, once again, B is going to be the pre-image, and then A is going to be the image. So, in other words, I guess if I were to write it out, I'm basically saying B, which is going to be -1 and then 5. If I throw it into the equation, x plus what and then y plus what, the result is that it's going to come out to be A, which in this case is going to be 6 comma 2. The best way to look at it is, again, remember, think about what we were saying about moving to the right, moving to the left, and so on, and then up and down. So what I can do is I'm going to take B on this graph right here, and I'm just going to go ahead and draw horizontal increments until I can get to where A is vertically. So counting that, 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 units. So that tells me, hey, I'm probably going to do x plus 7 in this case. And that makes sense because -1 and then plus 7 will then give me 6 then as a result. And then similarly, if I go down in this case over here, that is going to be -3. Then that tells me that probably should be y minus 3 then. 5 over here minus 3 is equal to 2. So there you go. My translation is going to be t of x comma y, the coordinate, any coordinate you want, and we're going to translate it by moving to the right by 7, and then we're going to move down by 3 as well. Okay, so there we go. Okay, now we're going to go ahead and introduce a new terminology, but it's really just kind of like a combination of the two that we've been doing so far. Okay, so this here, this new definition is called something called a glide reflection. Glide reflection. A glide reflection is a mapping. So all of this stuff, again, is going to be what is known as mapping. You know, like all the reflection and then translation and all that stuff. It's all categorizing as mapping, okay? Meaning like taking a point and moving it somewhere else. A glide reflection is a mapping where the set of points first glides and then it's going to reflect. So what that means is we're going to take a point and we're going to apply this glide or this translation to it. All the stuff that we've been doing so far in this section. And then afterwards, we're going to then reflect on top of that. So like I said, it's just a combination of this section and the previous section. So it basically is kind of like a way of saying that, hey, you can do more than just gliding and just reflecting. You can do maybe a combination of both. So hence, that's why it's called a glide reflection. Now, does it necessarily mean you have to glide and then reflect? No, you could reflect and glide, but this is just one example of it. So here is an example of that then, okay? Oh, and by the way, once again, this glide reflection over here is still going to be in isometry, meaning that whatever it is that you're gliding and reflecting, the shape of it is still going to be preserved. So at this point, you might be wondering to yourself, what isn't an isometry? And that's actually a very good question that we will come back to maybe in a couple of sections then, okay? But anyhow, here's an example of this glide reflection. Suppose that we have point P prime, which is supposed to be the image of P, and I'm giving you P right here, which is going to be 5, comma, negative 2. After you take the translation of T of fx, and then, T of xy, and then you're going to translate it by this x minus 3, and then y plus 6. Okay, so first of all, what I'm doing is I'm taking this point P and I'm throwing it into this translation. And the result is that I'm supposed to get some new point, which is going to be P prime. Now what I want to do, according to this, is then I want you to take that new point P prime and reflect it about the x-axis. And I want to know what's the new result. And also in part B, take that new point P prime and reflect it about the y-axis. So you can see that this is the glide reflection we're talking about. You're doing the gliding first, and then you're going to reflect it. Okay. All right. So I think it'll be ideal for us to find out where this point P prime is going to be, right? Well, I want to know where P prime is going to be located. Again, if we look at the numerical values right here, we're subtracting 3 and then we're adding 6. So that means the best way to look at it is we're going to go left by 3 units and then we're going to go up by 6 units then, okay? Because of what we just said earlier. If you want to throw the numerical values into there, you're going to definitely get the same answer. So I'm going to go across by 3 to the left. And then I'm going to go up by 6. So 1, 2, 3, 4, 5, 6. So 2, 4, 6. And I think I added 1 by accident. So there it is. So that point right there, that definitely looks like it's going to be P prime then. Okay. In terms of what that coordinate is, that is a coordinate of 2, comma 4. So check it just to make sure. P, which is going to be 5, comma 2. If I take 5 minus 3, comma, negative 2 plus 6, that is going to give me 2, comma 4. So there we go. It's exactly the same thing. So there it is. That's my P prime. Now what I want to do is I want to take that point and I want to, in the first case, reflect it about the x-axis. So in the last section, we're going to take this point P, reflect it about the x-axis, so meaning like, you fold the entire paper that you're drawing this on and fold it against the x-axis and find out where P prime is going to be. In terms of where that is, let's see, we're going to go ahead and draw a perpendicular going down. Looks like it's going to be 4 units. So that means if I go down 4 units more right here, because it's a complete perfect reflection. So then looks like that point is going to be over here, which is going to be 2, comma 1, 2, 3, 4. So 2, comma negative 4. So right there, that's going to be our answer then. Okay. So hopefully that looks somewhat familiar from the last section. And now for this last one, what I want to do is take that point P prime once again, But instead of reflecting it off the horizontal line, which is the x-axis, I want to now reflect it about the line y is equal to x. So first, again, I'm just going to go ahead and draw that line y is equal to x. So there it is. Okay, so remember, this line y is equal to x has a slope of 1, and that usually plays a critical part when it comes to finding the reflection, because now what I need to do is I need to find p prime, right? The slope of the line that is perpendicular to the line y is equal to x should have a slope of -1. So from this point p prime, I'm going to draw with a slope of -1, and right there, now you can probably see where the point is going to be then. That is the location of my after image, after my gliding, and also my reflection. So it looks like the point is going to be 4, 2. So there it is. That's going to be my answer, 4, 2. All right, well, there you go. Thank you so much for watching again, and I'll see you guys next time. Have a good one. Bye.